Welcome to the Time CNC Podcast, your go-to show for precision, efficiency, and innovation in CNC manufacturing. We're here to help you cut time in all of your CNC endeavors. Whether you're a CNC enthusiast, CAD/CAM aficionado, or into robotics, this podcast is for you. Join us as we explore cutting-edge perspectives on machining metal parts. Discover the perfect tools and streamline your production processes. Precision meets progress on the Time CNC Industry Podcast. And now, here's your hosts, Al Martins and Stephanie Bate.
Welcome back.
And there you are.
There I am.
Well, Steph, nice to see you back again after your trip to the Rockies. How was that?
Yes, it was awesome. Very awesome. But I did get a little sick, so I'll probably make you take the reins today.
You sound fine. That's what happens when you go to places that rain.
It doesn't rain there. No. They have problems with no rain in there.
I don't know. It's way too green to be without rain.
Yeah.
Places that don't rain is like, Dubai, and things are dry.
Yeah, I guess I was being educated that in BC it's like a desert there. So the grass is definitely it's a different type than we have here in Ontario.
Yeah.
Yeah.
they're on the opposite side of the Rockies, so their rainfall is a little less than the other side, but they're still green. For sure. It's beautiful. Anyway, welcome back.
Thank you.
So, Steph, tell us about our title and who's coming on today.
I'm going to read it because I don't want to mess it up. This is
No problem.
But we have a very exciting guest. It's Wayne Palombo, professor of manufacturing for Algonquin College. That's a mouthful for me right now.
Well, that's good. So what is, he's shaping the future here, right? So we have insights from a manufacturing professor. And it's the first time we've had a professor come onto the show, and we're excited about that.
Absolutely, it'll be a great show.
It will be a great show because ultimately I think he has a lot to say, and in the world of education, certainly there's not a lot of educators that I would say have a real keen desire an interest in helping their students, a very small percentage. And Wayne fits in that small group, and I'm honored to have him. I've known him for years and have a lot of respect for him. So looking forward to hearing what he has to say.
It's going to be, well, then that's a perfect segue for me to jump in the back and
adios.
Bring Wayne up. Have a good show.
Thank you, Steph. Talk to you soon.
Bye.
Bye. Hey, Wayne.
Hi, how you doing, Al? How are you?
I'm doing great.
Great to see you again.
Nice to see you, buddy. It's it has been a little while, and it's nice to reconnect and see how things are going over the years. And really honored that you were willing to take on the show and be our first educator. Really,
no pressure.
no pressure at all.
Yeah, hope I represent.
It's just interesting to get that perspective, and it's practical, and I think it's important that people who see our podcast understand that although it be trades and other things that we really think that I really think, and I think in general people in our industry of manufacturing believe the way students should go into the trades, your classes and education kind of train people in that direction as well. And I think it'll be a good show in regards to that. So can you tell us, Wayne, a little bit about you and how you got to where you are?
Sure, absolutely. So I have roughly 3 decades of experience now in the manufacturing industry, and been to university, been to college, and then put the theoretical and the tactile together and started working for Anarcan actually. And then from Anarcan, working in a neat little classified facility where I was fortunate enough to also be given a formal apprenticeship in tool and die making from some lovely European tool and die makers. From there, went on to aircraft, aerospace, medical device facilities as well. At one point in time, I worked for Canada's only artificial heart company. I was running that facility for the machine shop portion, which is where I first got experienced into Gibbs Cam. At the time, I was a Mastercam guy, using a myriad of softwares. And then from there, I left there and went back into the aircraft aerospace industry. And I actually ran my own company as the CEO for a number of years. And then after leaving that, became an educator of all things. Fell into it at Algonquin College, and that was approximately 19-ish years ago or so, and have loved it ever since.
Wow. I mean, that would take a while to unpack all of that. That's for sure.
Yeah, it seems like a lifetime ago, but I like to take all of those experiences and bring them into the classroom, if you will.
Yeah, of course.
Yeah, I think that's what's missing maybe a little bit in some ways. And for me, one of the things on how I transitioned into that just fell into my lap. I was on the PAC. So I was on the advisory board at Algonquin College as an industry member for a number of years as the CEO of a company. And when I had told the management at Algonquin College, by the way, I'm leaving this company. You may not want to send over so many people because the person that is continuing to run this corporation doesn't really believe in formal apprenticeship programs the way I do. And at that point in time, I was basically just offered a job along the lines of, well, where are you going to go? And I said, well, I'm probably just going to sit in a lawn chair for a few weeks. Think about that. I don't know if any of your listeners might have the fortunate or unfortunate idea of, if you're a CEO, it's a very stressful job. So I took a big break for an entire summer, and then just started teaching. Which ended up was my passion, because when I did have a company, even before I had my own company, I was always sponsoring machinists and sponsoring tool and die makers and making sure that young up and coming people that were passionate about that trade were given the proper tools, if you will. Like if you want this to be your job, I really do believe in formal apprenticeships.
No, agreed. Well, Wayne, the process of the show, and I know you've seen it before. We appreciate your subscribing and liking and doing all the things you're supposed to.
Of course.
We go through 10 questions. So we try to get through all 10 questions. We don't always, but we're going to do our best. And hopefully, by the time we finish those 10 questions, we'll have a good spherical understanding of really how, you as a professor have been able to look at the innovations in education and where we are today.
Sure.
So question 1, what inspired you to pursue a career in manufacturing education, and what keeps you passionate about it?
For me, the answer is easy. Because they're one and the same. What inspired me to even want to become a professional educator was that I was enjoying so much already. Even when I was running a corporation, I would go out into the machine shop with my suit and tie on. I would sit in a chair with some deburring tools, and I would leave my cell phone inside. And that was my way of hiding from the world, if you will, for maybe 30, 40 minutes. And I would take my lunch break in the machine shop. And I really enjoyed spending time boots on the ground, helping these young people, whether it was signing them up for an apprenticeship or maybe just showing them, hey, in terms of fixturing, that might not be the best way to look at this. And I really enjoyed the success that these people brought to the company at the time. they felt good about themselves because, of course, they were ameliorating and augmenting their skill set. And I felt pretty happy in that, these really clever young people were certainly not being exploited. I tried to find it as a conduit for them to seek higher education, whether or not that was a formal apprenticeship or something like that. So for me, that was an easy transition. I really enjoyed doing that as a professional in industry. And then when I was offered a really nice full-time position as tenured faculty, I knew right away that I would love that, just because I had loved it originally out in industry.
Well, that's interesting, Wayne. I mean, ultimately, I think, the idea of keeping passionate in it probably had a little bit to do with watching the development of your students over the years.
Absolutely. I'm fortunate enough that in this infrastructure, sometimes I will get a student as a first-year student, a second year, third year, and so on. And you can really see these people grow into their career. You also, the interesting thing, which still keeps me passionate to this day about manufacturing, is that it's such a diverse array of skill sets. You can almost pick your own career. If you are passionate about a particular area, you can just go right into that area, and that could be your area per se. So yeah. For me, that's really that's what really keeps me fresh, I guess you would say. Is I get to teach a wide array of subjects. I get a decent amount of autonomy at Algonquin College, where they're very good to me. Where if I express an interest to do something, they allow me a certain amount of poetic license to be able to, on a trust level, hopefully after 20 years of being there, and so that's what keeps me going. It's actually the young people, if you will.
Yeah, keeps us fresh.
Yeah, absolutely.
All right, well, that's super. Let's get on to question 2. So how has manufacturing education evolved over the years? And what are the most significant changes you've observed?
Well, the first thing that I would notice, which is a big standout ergonomically, is 20 plus years ago, it was very niche market. You were going to be a machinist, or you were going to be a tool and die maker. And then there were subfolders for that, if you will. You were going to be a CNC machinist. You are going to be a CNC programmer. And when I say these monikers, meaning that you would be relegated to, that is your one and only career. You will only seek this option. You will be a CNC programmer. You will never leave your desk. You will never machine a part. You would go into, so that was how it was, 20, 30 years ago. What I see now in modernity, in 2024, is you have a less niche oriented form of education. It's less stylized towards one tiny little subset. And now you have a little bit more of a broad-based education where the scope of subjects can range anywhere from robotics to AC/DC electronics to pneumatics to CNC programming, of course, and machining, manual machining. But I think nowadays it's a more broad stroke education, which keeps up with the times a little bit more in terms of all of the infrastructure that's out there in industry. It seems to me, when I visit companies, I see a lot of various job roles, and to only have an education that would only allow a student the chance to have one of those, it would be a limited education. So that's a big change that I've seen.
Yeah, and I would say, along those lines, I mean, it was the time, when I was doing my apprenticeship, we'd be using a lot of manual tools. I mean, we had to file a cube.
Yeah.
We had to run everything on the Bridgeport or on the conventional turning center. And I would say that those have been replaced with obviously CAD/CAM and maybe even some AI generated solutions.
It certainly has.
Changed, eh?
one of the things that we do at Algonquin College, again, I can't speak for all colleges, but I'm pretty proud of the program offering that we have, which is we still maintain a relatively robust aspect of manual machining skills as a precursor for all of the CNC courses, whether it's programming or machining or setup or fixturing. And because I believe we have a system in place that we've developed over the last 20 years, which is before you tell somebody to run, for example, a 3-flute, solid carbide tin coated end mill at 45,000 RPM, how many holes have you drilled with a high speed steel bit? And how good are you at the math? Do you understand chip load? Do you understand radial chip thinning, chip per tooth, feet per tooth, all of these things? So we are very strong on making sure that they have good, strong fundamentals before they go on to CNC.
And that's crucial. And I think that also speaks to your understanding of the subject and being able to push that into the system. Otherwise, it would always be we'll say a shorter course to a solution.
Yeah, I think it's really important in any career, really, to have those fundamentals, because what I've noticed, at least for my own career out in industry and not as an educator per se, was that every time that there was a problem that was very difficult to solve, you almost always somehow had to revert back to those basics. What are the math? Why is this cutter dying? Why is this not working well? Why is this fixturing failing? Why can I not hold the tolerance? And I think starting at the level of manual machining and making sure that those fundamentals are there is really critical, because if you don't understand that, going faster doesn't necessarily mean you're going to solve that problem.
No, absolutely. All right. So super. Number 3, what do you believe are the key skills and knowledge areas that students entering the manufacturing field today must possess?
Oh, wow. That's a great question.
Yeah, that is an interesting one.
Yeah, that one is pretty open-ended. Again, I would probably revert back to what I had mentioned a little bit earlier, which is now the students in 2024 are expected to know so much. Now, you're not expected to be an expert. I mean, I do visit companies every summer. I go to Montreal, I go to Toronto, obviously I'm based in Ottawa. I visit a lot of companies, and they all tell me the same things, that they're looking for students that have skills. So, and by skills, they're talking about physical tactile skills and the intangible skills as well. Do you have good interpersonal skills? And what are your actual tactile skills? So regarding the manufacturing field and what they need to possess, I would say it's more demanding than ever, because I hate to say it, but to rip the Band-Aid off, the world is more demanding than ever globally. And in order for developed nations to really produce on a large scale globally, you have to do it with keen insight and good technology. So I think leveraging technology is a huge aspect of what students need to possess right now.
Well, I agree, but when you look at key skills, I mean, social graces used to be taught by the parents. Things have changed in society a little bit, so that is something. Interpersonal skills and communication have also suffered because of the devices people use. They'd rather sit there and text you rather than open their mouths and talk to you. That's
for sure can be a curse or a blessing.
You can see them sitting in a restaurant. Hopefully they're texting each other. I don't know.
Maybe not always. Yeah.
But, and in Canada, there's a lot of the students come in with a deficit, sadly, because, they spent their early years in school not learning Imperial. They can't read a measuring tape. They can't read a vernia. They don't know what 20 thou is. and now you've got to, get their skills up just to understand what imperial measurements are. And I've had that argument with education for years, but
well,
they don't listen to me.
Hopefully I can give you a ray of sunshine then, because I do. One of the main subjects I teach at Algonquin College is metrology, or the science of measurement.
Sure.
And although Canada, of course, is a metric company, here's where I can bring in.
Not really.
Yeah, agreed.
Not really.
I suppose. Here's where I bring in my industry experience to the classroom, and I tell them, look, the company that I ran right before becoming an educator for a number of years, we were a defense contractor for the Canadian military and for the U.S. military. So yes, Canada's a metric country, and we're most certainly going to teach you something about the metric system. But here's the reality of what you're about to machine or manufacture. Mm-hmm. Probably more than 90% of the blueprints or drawings that you're ever going to see is in imperial measurement. So although you're coming from various countries around the world and very, very clever young people, including locally, I almost always, the first few weeks of a measurement course is exactly what you just said. I have to make sure that before we go on to more complex concepts, like thread measurement and things that are much more complex, like sign calculations, things like that, I have to make sure that something as simple as somebody understands what 3.5 thou means.
Yep.
And which of course is a language barrier. I mean, you and I have known each other a long time. We come from some cultural backgrounds where we speak a few languages.
Yep.
So I'm always sympathetic and aware, or try to be, to the immigrant plight who comes to the country and maybe English isn't their first language.
Yeah.
It can be difficult to explain to somebody whose language skills might not be super strong, and you want to help them because you see they're very clever, as to, what does 2.5 thou mean?
Well, exactly. And I think, to your point, ultimately math is another language. And, we shouldn't be, we'll say, crippling students' positions. I mean, this question, we could go on this for a long time, but what prerequisites, what skills do you need? Certainly in North America, if you don't have a good idea of what imperial measurement is, get boned up on that, because you're going to need to know that.
Yeah.
Because Canada is a tiny, tiny little economy who lives next to a giant, and certainly we have been imperial for a long, long time. And we need to work in it every day as manufacturers, whether you're a carpenter, whether you're a machinist, anything to do in that world is going to be imperial. So learn that.
Yeah, agreed. Well, it's certainly being taught at Algonquin as well. Again, I can't speak for other colleges. Hopefully, I'm sure there must be some very strong colleagues at other facilities, but I can at least speak on behalf of Algonquin. It's definitely being taught.
Oh, you have no choice. But what I'm saying is, in high schools and
oh yeah, that's not being taught there. I can assure you,
it's not being taught there, and that's a problem.
No, it's not. I mean, I would say I'm speaking on students that probably graduated high school on the honor roll or the dean's list, or whatever it might be called in high school nowadays.
Mm-hmm.
So these are very bright students, very, very mathematically inclined. I mean, just they have to be even to be accepted into a mechanical engineering or manufacturing a program at post-secondary. But it's almost like being dropped off into another country where the high schools have not really done them a solid in terms of they have no idea what imperial measurement is. So we start at ground zero, it seems.
I know. It's anyway. For any of you Board of Education people, pay attention, will you? Pay attention, Brian. Get those people trained in imperial and metric.
Yeah.
So that they can get to, when they're in the world of manufacturing, they can be useful. Anyway, question number 4.
Yes, sir.
How are you integrating emerging technologies such as automation and AI into your curriculum to prepare students for the future of manufacturing?
Well, we don't have manufacturing cells in the way that a giant conglomerate, like let's say a General Motors might, but what we do have is standalone cells, if you will. So what we have done in all three of our programs at Algonquin, in that we do have robotics labs dedicated to robotics, if you will, like pick and place machines, Allen Bradley, Fanuc robots, things of that nature. So they're learning how to use the robots, how to program the robots, the software, the infrastructure fixturing for that. And they would have individual classes as well in terms of CNC programs, CNC machining, and how these two would actually physically go together. So this was a real major shift I've noticed. I would say in the last 10 years, Algonquin is, and I think just in general, North America in general, has put a major emphasis on understanding the benefit of robotics. I mean, you only have to look to an Amazon warehouse to understand the benefit of robotics, right? So, I mean, if you're not learning that in post-secondary, you're certainly at a detriment. So I think any good quality education must have some component of physicality, of combining robotics, AI, machining, fabrication. You need to know, because nowadays, as you know better than anybody, this is a symbiotic relationship. They are one and the same now. You can take your career, but you really can't unmarry any of them. Any facility has them all now.
Yeah, that integration is going to get blurred more and more as we move along. No question about it. Things are getting faster and smarter, and I think you said earlier very clearly, if we want to compete here in the West, we have to be good at all of that. You know, in other countries, you could have a 3-axis mill and a 2-axis turning center, and have labor on both machines and still be significantly cheaper than here in the West. So here, what would you do? Well, maybe get a mill turn center, maybe load and unload with robotics and keep it down to 0 or 1 guy for 2 machines or 3 machines, right?
Yeah, absolutely. What I see more so, I'm very fortunate in that I have still maintained a lot of industry contacts. Good. And in a lot of cases, they might have been people that I went to school with, what now seems about 1,000 years ago. However, some of them, I'm proud to say, are my former students. And I visit some of these facilities where it's students I might have graduated 10, 15 years ago are now, directors of operations, CNC programmers and stuff like that, where I go in and I see these facilities. And it's certainly, it's almost breathtaking to watch how much technology has advanced. Yeah. And North America definitely requires to leverage that, I've seen. So the companies that seem to be flourishing, where I'm getting inundated with emails saying, hey, how many graduates do you have this year for me? There seems to be a direct correlation, 1-for-1. When I visit these companies, these are 100% of the time, these are companies that are leveraging technology. These are progressively minded companies. Yeah, we certainly can't stay in that traditional mindset. And that's what kind of sets you apart as a professor, is exactly what question 4 was about. It's staying current with the technology. Oftentimes, schools kind of teach the same thing over and over and over again, not recognizing that every year, and now it's almost monthly, technology is changing that quickly. Yeah, I think it's absolutely critical. I think you are doing a disservice, to be honest, to your students, if you are not going out annually or more than annually, biannually possibly, as your schedule would allow, and to visit some major corporations all the way down to job shops. I like to go to a major tier 1 corporation, like a Lockheed, and then all the way down to maybe a machine shop that may only have 12 employees.
Yeah.
Because sometimes these facilities, which may not have a lot of employees, these are the facilities that are heavily leveraging technology because they have to. These are the creative facilities. I've learned a lot, to be honest, by simply maintaining these industry contacts. And it's a breath of fresh air to be an educator and to go back out into industry and to actually continue to learn.
Yeah, absolutely. That's, that lights out. Anyway, we're touching on question 5 a little bit. So what role does industry collaboration play in your teaching approach? And how do you engage with manufacturing companies to stay updated on current trends?
Well, like I mentioned, I literally will bring curriculum with me. So, I touched on it briefly, but to get a little bit more specific, what I might do is I might bring a laptop. I might bring maybe a tablet. I may even bring some aircraft aluminum components or, assemblies that students might make. And I would say, ask some questions. I'm not here to drive industry, right? I'm here to listen.
Yeah.
And I think that's the role of an effective educator. I'm there to go out there, and I certainly don't have an ego. In some cases, it's my students from 10 or 15 years ago. They're teaching me now. Wayne, we don't do it that way anymore. God bless you. But come on over here, and I'm going to show you what we do. And with this machine, with this type of modular fixturing, it might be. And I will, as best as possible, as finances will allow, I'll bring that back to Algonquin College, and I'll try to make sure that at least the academic value as to what they're doing with something like modular fixturing, maybe I'll go back and we'll still manufacture that same assembly. But now, instead of using something like a 6-inch chick vise or a Kurt vise, maybe now we're looking at a modular fixture where we can have all of the operations done on this one fixture. And that helps them, the buzzword, of course, that we would probably use, in education land. We would hope that they would be more employable.
And ultimately, that's what it's about, right? They pay a tuition, and their goal is to maybe touch on that, Wayne, a little bit. What is, when somebody graduates from your class, what is their employability ratio?
Well, again, that really depends upon. So I spoke about like that broad-based education, and with that, you're looking at the possibility of somebody going into quality control. You're looking at somebody going into CNC machining. You're looking at somebody maybe getting a formal apprenticeship for manual machining, that might be their first year, and they would foray into something else. CNC programming. It's such a diverse array as to where they might get their first landing job. In terms of finances, it's across the board. Like I would say, unlike a lot of other careers, which might be very heavily unionized, like maybe a nurse or a fireman or a policeman and so on, if you graduate with a pretty high GPA in any type of manufacturing environment, what I have noticed, at least, on the other side, is students are receiving approximately 2 to 3 job offers before they've even graduated.
Yeah.
So, your employability, loosely, I don't have a hard statistic for you. I'm not a data analyst or bean counter, if you will, at Algonquin, but I can tell you the people that are finishing these programs are not suffering to find employment.
Yeah, and that's what makes this show, I think, intriguing. It gives them a head start and understanding, hey, if I'm going to pay tuition, I want something from that. And that'll be a job, because you will definitely be employable.
I think it's always been undersold. I don't know how you feel about this, Al, but I think possibly even in our time, it may have been undersold as a viable opportunity and maybe misunderstood. even still to this day.
I think the inherently, I mean, again, I could digress a little bit here, but as far as educators go, the longer kids are in school, the better it is for them. It's not much different than pharmaceutical companies. The more you're sick, the better it is for them. The inherent, what is the best for the student is, I think, never been overly quantified certainly in the last 50 years, I'm going to say. And again, this could be controversial to some, but the longer they're in school, the more teachers that are employed, the more tuitions that are collected, and so on and so on and so on. So, and not a lot of people understood the technical side of things. It was really the shop guys, and they were a minority in the group, and they were always looked at, as insignificant humans. They can't be that important. They're wearing blue.
I mean, I see, I'm fortunate enough to visit companies from all across Ontario to Montreal. I certainly see less of that now. But I can tell you, at least because you and I are in the same age demographic, the struggle was real back then. So even though I might have, the career that I really latched onto was that almighty apprenticeship with a wonderful human being who's no longer with us anymore. His name was Jose San Juan, gave me a chance in this world to be a tool and die maker. This was my real passion. And although taking the university and the college and putting them together, and then starting to wear that blue uniform that you mentioned, and then realizing, oh my gosh, every single person in this building is smarter than I am. and you showed up, thinking, boy, I'm a real firecracker. I've got this, boys. And then you realize, I don't know anything. These gentlemen are brilliant. That's really eye-opening.
Anyway, we could go down that road for a little bit. So number 6.
Yes.
From your perspective, what are the biggest challenges the manufacturing industry is currently facing, and how can education help address these issues?
Well, I can at least be a megaphone, if you will, for the companies that aren't here today, because I do go out and visit these companies, and I'm fortunate enough that they let me in the building, usually because they have some great foresight in that it's in their best interest to have a student coming in the door that is maybe more relevant to them. So I can at least tell you what has been told to me from various manufacturing corporations across 2 different provinces. And they all, regardless of which province they're in or even which language they speak, they've all been telling me the same thing. They are looking for young people with skills. And that is it. So take from that what you will. They could be referring to CAD skills, CAM skills, tactile machining skills, but they are not interested in what you and I may consider the fluff or the intangibles. Can this person actually read a micrometer? Can this person work alone for 8 hours and read that drawing? So I think that if I were to echo what the industry is telling me, they're looking for skills. And for us, at least my classes, and what I've seen a big shift, at least at Algonquin, is we have put the brakes on just having endless amounts of projects. We put the brakes on that, and we've now mitigated it down to a much smaller amount of projects, going a little bit slower and really focusing on that individual machine per se. So I can speak a little bit based off of my own career. When I was started on a CNC machine, it was press the green button, hit it with a hammer, use a torque wrench, blow off the coolant, don't open your mouth, do a good job. Every third part, pull out the micrometer. These parts better be good. Sign your name. If you're good, maybe one day the heavens will open for you and we'll give you a raise, right? That was kind of old ways, if you will.
Yeah.
Whereas nowadays people are very interested in training people, and they're looking for people that have entry-level skills. So I don't want to scare off any potential students that may be looking at this, because in some ways I think the education has become maybe not easier, but singularity of focus on those skills. Don't worry about having a workload that is going to keep you up till 4 o'clock in the morning. Now, it could be something as simple as when I teach somebody how to use a lathe. You're going to leave that 14, 15-week semester with the knowledge on how to run that machine. Don't worry about how many projects you did. So I've re-energized my focus on what companies like Bombardier are telling me, GE, whether it's Boeing, Lockheed, it doesn't matter who's, or if it's here in Ottawa, some of the smaller machine shops, they're all telling me the same thing. Please make sure they can read a micrometer, vernier caliper, understand what a dial indicator is, sine, build, that, that's kind of simple stuff, but the basics.
The basics. And I agree. I mean, when you look at the situation, going to industry and asking them what they need is important. And then knowing what they need, acting on it. And you were always good at that because you came from industry.
I think it's vital. Yeah. I think, to be honest, I can't speak for other colleges. I've never taught at another college. But just being active in that community, I feel like there can be a tendency to overhire based off of lofty educational titles, as opposed to maybe not bringing in some real world value. Which, based off of the corporations I'm visiting, seems to be paramount to them.
Yeah.
That their students can actually do the job.
I agree 100%. And, it's no different here. The CV that says you have these many diplomas means nothing to us. Absolutely zero. We want to know that you can do the job.
I mean, how many people would you have seen in your vast career that have told you, don't worry, I can CNC program this part. Like, I'm an expert, right? And maybe they can't.
Yeah, no, it doesn't work very well. I can tell you that. All right. So number 7, and I think this is a nice one, and hopefully you've got a couple of stories there. And if you don't, I can fill in a couple for you.
Oh, I have it on good authority that you could, yes.
No. Can you share a success story of one of your students or graduates who has made a significant impact on the industry?
Well, I've got a number of success stories, and I would hate to single anybody out, but I can tell you where some of the students have ended up and some of their job profiles. Because most of them, I'm blessed enough that a lot of them will add me on social media afterwards and keep in contact with me. And I like to follow them, and they'll follow me and see their success. I have one young gentleman who ended up being one of the head CNC programmers at Boeing here in Canada. I had another young gentleman who ended up, when he got engaged, went over to Italy and visited the Ferrari plant. And his background was he was actually born in Italy, but lived in another country abroad for most of his years, came to Canada for his education, got engaged in Canada, went over to the Ferrari plant just for the tour, and ended up landing a job. And so he's in Maranello. So he's a graduate of our program now, making Ferraris over in Italy, if you will. Yeah. We've been fortunate enough to place young people as far as Burlington, as you know, all the way to Montreal, from Lockheed, Bombardier, Boeing, all of these amazing, McDonnell Douglas, General Dynamics. Some of these young people are directors of operations, CNC programmers. I mean, the success stories, virtually, there's at least a few every single year. Um, these are unbelievable careers that some of these people are having.
I can see, back to question 1 and question 2, how that invigorates you to want to continue and help more and more students become successful. That's wonderful.
Absolutely. I think, not to harp on social media, but it really, when you see where somebody ends up in 5 years from now and 10 years from now, it definitely reinvigorates you to, like, well, you know what, whatever this little microcosm of teaching that I'm doing in Ottawa has made a difference to somebody's life, somebody's family, somebody's career, and so on. They go on to be successful. They have home ownership, married with children, happy people. And you think, boy, maybe it was all worth it. Possibly taking a lower salary as an educator, as opposed to staying in industry, right?
No, absolutely.
You're there because your heart's in the right place.
And you might, be, hopefully, maybe, inspiring other educators. Like I say, I think you're in what I call the 1 percentile of educators that I've met who have that type of passion for manufacturing and the genuine interest in getting students into industry to allow them to generate a good revenue for their families.
Yeah, I think you have to. I think it's like athletics, to be honest. I think you either have that passion or you don't.
Yeah.
I'm not sure you can teach somebody passion.
Yeah.
And for me, I was just fortunate. I lucked into this career where somebody gave me a chance. And to this day, I mean, if this gentleman was still around, I would still continue to thank him.
Yeah.
I've never had a boring day ever.
No, it's always a different day. All right. Well, let's get on to number 8. What advice would you give to someone considering a career in manufacturing today? Are these specific sectors or skills you recommend they focus on?
Most definitely. So if somebody is even remotely interested in any one of these TV shows, like How It's Made, or any of these YouTube channels that you're watching, like yours, and there's so many robust YouTube channels now out there, when you're not just relegated to cable TV, if you will, from years ago. Yeah. If you're considering a career in manufacturing, I would definitely say to not just worry about these high school classes, like your basics, if you will. Don't be afraid to wear a blue shirt, go into a shop class in high school. You will not be thought of as a lesser person, if you will. This is not 1955. It's not 1986. In today's day and age, I see more and more students that are making the dean's list with 80s, 90s, and 95, like 3.9 GPAs. These are brilliant people in mathematics. And they've told me in every year in high school, they took shop class.
There you go.
So we are now looking at students that can weld coming out of high school, who also are phenomenal at things like physics, statics, calculus. Like these are brilliant young people that are putting these tactile skills together, if you will, of it's okay to work with your hands. So if I were to give anybody advice today, this contemplating going into manufacturing, I would definitely say, don't just worry about your grades in algebra. Don't be afraid to get your hands dirty a little bit. Go take a shop class, because this has just as much benefit to you in terms of teaching you what you may really love in life.
I agree. And I think, manufacturing, that discipline kind of marries almost two sides of your brain, because you've got to be mathematical. You have to be analytical to understand what it is you're doing, but you also have to have some ability to be creative at all times. And that kind of came to your point, how are you going to fixture this job? How many sides am I going to attack? What type of machine tool am I going to pick for this? And that creative side is is really, it's a discipline, I think, that handles, I don't know, a full range of brain, more so than just a specific vertical.
I think it's important for other post-secondary educators to actually visit high schools as well, which is something that I do. So, I mean, although I'm not so sure Ontario colleges are flush and swimming with money the way industry is, if I'm being perfectly transparent. Mm-hmm. However, I would say it's probably fairly realistic that we may have more funds available than the average local high school. Mm-hmm. So what I try to do, at least here in the local Ottawa area, is visit local high schools and give some donations of maybe tools that aren't quite razor sharp anymore. We can't really use them for our applications. We don't really need that giant chunk of tool steel any longer. Or, we don't use projects out of this aircraft aluminum any longer, that shape and size. I know it's going to sit on a rack forever. So I actually visit the local high schools, and I try to, via donations, and even offer some curriculum support. Like, hey, if I were you, have you thought about maybe doing more of this or less of that? Because ultimately, for guys like you that are in the industry, if I can get, or an educator at post-secondary, if I can get a student that is a little bit stronger in the skill set coming in the door at college, then I can hit the ground running, and I possibly could do a better job. I can be more effective, and I would be able to give a better product to industry.
Yeah, and that is really, really nice to be able to do that. That's fantastic that you take that effort. So number 9, how do you see the role of manufacturing education evolving in the next decade? And what changes would you like to implement in your program to stay ahead of the curve?
Well, that's a pretty open question.
It is, isn't it?
Oh boy.
It's a long one.
Yeah. Where do I see manufacturing engineering education evolve to? Well, I see it already evolving into more AI and just more use of softwares offline, if you will. I think gone are the stuffy days of a lecturer with a tweed jacket and a pipe sitting in front of a class for 3 or 4 hours and boring.
Yeah.
I mean, just even in something as simple as a 60-minute 1-hour measurement theory class, I mean, you have to use technology just even in that. I mean, I've built interactive tools where students can actually via software, they can take an actual micrometer that's in their hand, open it up, look at that, and then I've built a software where they can physically, there's an AI micrometer that they can open and close, and it gives you the readouts. So it teaches you how to read while you're even at home. So students can actually be at home and still learn how to read a vernier and how to read a micrometer and other things that they otherwise might not be able to, because maybe the average student can't afford a really good quality 6-inch set of Starrett calipers and a full 1 to 6 micrometer set. That's maybe not very possible for a college student to maybe spend $1,000 on good quality tools. So I think it's really important where it's going nowadays is I think teachers need to leverage technology where it's not just shooting up PowerPoints and YouTube videos, or just to watch this while I go sleep in the corner. You have to really put an effort in finding a software and build a tool that people want to use.
Well, that's interesting, and that's very creative. 10 years is a really, really long time, and where things will be from there is really tough.
Yeah, I mean, it's certainly tough to guesstimate, but I mean, I certainly can't see there being less AI.
Definitely not. I mean, there's AI in just about every piece of software that's out there now. In Tool Manager IQ and Gibbs and and all kinds of other software packages, they exist. It's interesting to see. I mean, in the old days, we had what was it? The machinist handbook.
Oh yeah, that's right.
Volume 11, volume 12, volume 13, almost every year we'd have another one.
Yep.
And today, you don't know what the tap drill size for a quarter 20 is. Just ask the AI.
Yeah, absolutely. Well, I mean, you and I might be able to crack the same joke, which is, I don't know about you, but most of my teachers, when I was in, grade school, when I was a young lad, they would say things like, "What are you going to do? You're never going to be able to have a calculator with you." Well, as it turns out, everybody has a phone and a calculator and a camera and anything else and ChatGPT or anything else. So turns out they were wrong.
Yeah.
However, I would certainly, if it's me, I don't want to fall prey to the same curse. I don't want to ever tell a student you'll never have that with you, because I at least want to acknowledge that you probably will have some incredible form of technology with you to help.
Yeah. Yes, you will amount to something. Absolutely.
Yeah.
All right. So our last question.
Sure.
Lastly, how important is it for educational institutions to adopt quickly to technology advancements, and how do you manage that balance between theory, practical, hands-on experience?
I think you have to work with the industry. You can't do it alone. It's a multi-diverse answer, Al, to be honest, but it's simple. If you are a standalone unit and you're a teacher or you're an educator and you just want to teach whatever subject that you feel strong in, God bless you. You're probably doing a great job, but you're doing a disservice if you are not bringing industry into the classroom. What are we doing for fixturing? What are you guys doing for radial chip thinning in your softwares? What softwares are you using? Even if it's manual machining, which there's still a robust amount of manual machining happening. You have to bring industry in here. So for me, I would say educational institutions need to adapt and bring in that technology by working with industry, because otherwise you're talking about that old adage of don't put the cart in front of the horse type of thing. How could I possibly tell industry, yeah, this is how we're going to do it? I think you need to check your ego at the door, and I think you need to hop in your vehicle. You need to go around and maybe see and be enlightened. Wow, things are moving fast. I can barely keep up, but it's my job. I mean, for me, my paycheck, although Algonquin College, of course, would argue that they write me a paycheck, they would certainly be correct. The way that I've always approached it is I believe the students write my paycheck. So I always try to keep that in mind regarding technology and advancements.
I think too, and I know our show is almost over here, but the class demographics as far as age.
Yeah.
What are the age types that you're getting in school now?
I would say it's a broad array of ages now. So I would say 20 years ago when I started, you were really relegated to students fresh out of high school. You were talking about young ladies and young men that were probably in the 18, 19 age demographic. Now you are seeing people married with children. They might have already had a career that fizzled out. And now, guess what? They need to come back and take something that actually has a job at the end of the tunnel. Okay. Yeah. And in some cases, they may have been loosely in the field of manufacturing, but now they want to get a formal education in it, because now that'll allow them to increase their earning potential, or maybe move up in that particular company. So I see a broad base. I mean, we're talking about people as old as I am, which is in my 50s. Believe it or not, I've had people, I had somebody take a manufacturing education that was a retired physician.
Isn't that interesting?
Who actually was just fascinated with the tools that he had been using for surgeries, and he just wanted to know, how are these things made? So this was a hobby course, obviously, for this gentleman.
Yeah.
But I can at least say that I've had people well in their 50s all the way down to about 17 years of age. So it's a pretty broad base nowadays, and of course from other countries.
Yeah, I would say, and that probably even you would have, do-it-yourselfers, as it were, who can afford a little CNC machine in their garage, who want to have a little better understanding of the industry or of the application.
I see a lot of, Al, you touched on something pretty interesting. I'm glad I didn't forget this. Because I think this touches on a few questions that you've asked. What I do see now, to be honest, is I see a lot of people coming in to the class already. I'm talking about semester number 1. Hi, my name is. I just met them. They're a brand new student. It's the second week of school, and they're telling me already I have 2 3D printers in my bedroom. I have 2 MakerBots, or regardless of the brand. Yeah. And they already have these skills. They've printed a bunch of objects already, and they're coming in with strong CAD skills, believe it or not, that just were not there years ago. Yeah, it's impressive.
It is cool. Well, Wayne, it's been wonderful having you. Thank you so much for this. The interesting thing about the internet is this will be on for, as long as the internet exists, I guess it'll be out there in space.
It's forever.
I don't want to give it a number because it might change. But certainly as long as the internet's available and as long as we're out there, people will be able to watch this. This will be out on Spotify and the Apple podcast tomorrow, I believe. Amazing. And I want to thank everybody who watched us today live and look forward to seeing you on our next podcast. And Wayne, thanks again. I'm going to bring Stephanie on and she'll introduce our next guest for our next podcast.
For having me out. Thank you.
Thank you, Wayne. Cheers. Thank you.
Thank you.
Thank you.
I'm back.
Welcome back, Steffi.
That was a great one. Good job.
Yeah, it was. It was really nice to see Wayne again. It's nice to see somebody as passionate as he is, especially in education.
Absolutely. A lot of good info there.
So when's our next podcast and title and who's coming on?
Okay, so next podcast is November 13th. Hard to believe we're already in November.
Yeah.
And it's called Crafting Success, How Veritas Proves Manufacturing Thrives in North America. I'm running on little sleep, so the brain is not working. And it's with Rob Gauchi.
It's funny. Wayne's probably thinking, I know that guy. I know that company. So it seems to be an Ottawa kind of week or month.
Yeah, absolutely.
Well, Steph, thank you for co-hosting. This has been brilliant. And I'll let you close off the show. And thank you, everyone, for joining us. And please like and subscribe and do all the things that we hope you do.
Thank you so much.
Thank you, Steffi. Bye. Ciao.
Thank you for tuning in to the Cutting Time CNC Podcast, where precision meets progress. We hope you've gained valuable insights into CNC manufacturing and are inspired to optimize your processes for efficiency and innovation. For more resources and to connect with Al or Stephanie, visit us at cuttingtimecncpodcast.com. The link is in the show description. Remember, the journey doesn't end here. Keep exploring, keep learning, and keep pushing the boundaries of what's possible in CNC manufacturing. Make sure you follow the show on Apple Podcasts, Spotify, or your favorite player to get notified about new episodes of the Cutting Time CNC Industry Podcast.